Hi, this is Mrs. V with a short little lecture on the difference between molecular and empirical formulas. So after this lecture, if you're still a little confused, again, you can completely go to your chemistry book, and on pages 309 and then 311 to 312 is really the information that I'm kind of giving here. So feel free to go ahead and read those pages. Okay, let's start off with a couple definitions. So, definition of empirical formula. This shows the smallest whole number ratio of the atoms in a compound. So, it's kind of like the simplest fraction. So, whenever your math teacher tells you, please reduce to the simplest fraction, that is the same idea here in chemistry. We are going to reduce to the smallest number of smallest subscripts in a formula. Now the molecular formula is completely different. This is the one we usually use for balancing, and it represents the exact number of atoms of each element in the compound. We'll go over a couple different ones, but here's an example. So something like C6H6, that is the molecular formula. That is what you are going to see in a chemical equation for balancing. But the empirical formula here is CH, because I can divide both of these by 6 to just get 1. So it's making the smallest whole number ratio is empirical. Let's go over a little bit more of empirical. So empirical, like I said, is the smallest whole number ratio of atoms in a compound. It's like a reduced fraction. And it gives us the ratio of atoms, which tells the type of compound it is. So that's what we kind of use it for. So we don't really use it in balancing equations. We don't use it when we're figuring out moles or any of this other stuff as you go forward. But if it's easier to write, because I've always told you scientists like things that are much easier to write. So the empirical formula we really use as a ratio. Just a basic ratio 1-to-1, like the one you just saw, which was C6H6. The ratio of carbon to hydrogen is really 1-to-1, half and a half. And so that by doing the empirical formula, we can actually organize them and put them into different type of compounds very quickly, like carbohydrates, or like in biology, lipids, or nitrogen bases. Okay, we can quickly group them very easily without worrying about the numbers, okay? Because everything that has a 1-to-1 ratio could be classified as a hydrocarbon, okay? Or a carbohydrate can have, usually has carbon, hydrogen, oxygen in a certain ratio. So by reducing them down to the empirical formula, we can quickly just look at something and go, oh yeah, that goes in that group, okay? Because they're all going to be the same. An example here is hydrogen peroxide. So hydrogen peroxide, you usually will see it as H2O2, and that is a molecular formula. That is what we use in the balancing of equations. But the empirical formula here is actually HO, because both these numbers can be divided by 2. So it's a 1-to-1 ratio of hydrogen and oxygen. And that's what the empirical formula tells me, okay? Is just the ratio of the atoms or the elements. How about the molecular formula? What do we use that for? Well, this is the actual number of atoms in a compound. It's like the unreduced fraction, such as 2/4. Okay, so 2/4 is like a molecular formula, and 1/2 is the empirical formula. Okay, and we use this formula in chemical reactions for balancing. And this is usually the one you guys are going to see is the molecular formula, not the empirical. Okay, so here's another example of sugar. Sugar is a carbohydrate. Okay, here's a good example of putting them into groups. It's C6H12O6. That's the molecular formula. There's 6 carbons, 12 hydrogens, and 6 oxygens in the molecule. But the empirical formula I can divide all the way across by 6 is CH2O. That's the empirical formula. Now, if any time I'm looking through a bunch of different molecules, anything that has a CH2O automatically is a carbohydrate. Okay? So that's why we use those empirical formulas. You guys aren't going to be really exposed to much empirical formulas, but I wanted you guys to go ahead and get kind of an introduction as you go forward. So just remember, molecular formula is like the unreduced fraction, while empirical is the reduced fraction. Okay? So let's do a little practice, okay? And I'm going to have you guys pause this video in just a minute. I'm going to go through these, and I want you guys to practice and see if you can make the empirical formula. So our first one here is C2O2. These are all the molecular formulas, and I spelled it wrong. I'll have to fix that. And we have CH2O, and then we have C2H4O2 and H2O. Now, notice some of these, the empirical formula may match the molecular. So if you can't reduce it, then it's the same. Okay, so take a minute, go ahead and pause the video, and I want you to write the empirical formulas. Each of them are going to have them, but they may be exactly what the molecular formula looks like. So please pause the video. Okay, well, I hope you guys gave it a chance and gave it a try, but let's look. So the empirical formula of number 1 would be CO, divide both by 2. The second one, that is the molecular and the empirical are exactly the same. I can't reduce it. Number 3 would be CH2O. And number 4 would be H2O. That one I can't reduce either. So I hope this helped a little bit, understanding the difference between molecular and empirical. If not, please get a hold of me. Till next time.